Hey there, welcome back to the channel. Today, we're exploring a fundamental concept in Unity 3D that's crucial for understanding how objects move and interact within our scenes, local and global positions. Whether you're just starting out with game development or looking to deepen your understanding, mastering these concepts is key to creating dynamic and immersive experiences. In this video, we'll break down what local and global positions mean in Unity 3D, why they're important, and how you can effectively utilize them in your projects. By the end, you'll have a solid grasp on how to manipulate objects relative to their parent and world coordinates, opening up a world of possibilities for your game development journey. So, if you're ready to level up your Unity skills, let's dive right in and explore local and global positions together. First is transform.position, also referred as global position. This property represents the position of the game object in the world space. It is a vector 3 value that specifies the position in the coordinate system of the game world, regardless of parent game objects. If you're not familiar with what world space means in Unity 3D, click the link I've provided at the end of this video to learn more. It'll help clarify any questions you have about this fundamental concept. Now, let's dive into understanding local and global positions in Unity 3D. For example, if I set GameObject's position to 5, 2, 3, it means it is positioned at 5, 2, 3 units from the origin of the game world. Second is transform.localPosition. This property represents the position of the GameObject relative to its parent GameObject, if it has one. It is a vector 3 value that specifies the position in the local coordinate system of the parent GameObject. By default, in Unity 3D Inspector window shows selected GameObject's local position. For example, if I set GameObject's local position to 1, 0, 0, it means it is positioned 1 unit to the right of its parent's origin. Now let's check both cases with creating GameObject. Now I am creating GameObject A at 2, 3, 0, in world space. I create GameObject B, which is child of A with local position set to 1, 0, 0, then A's position is 2, 3, 0. B's local position is 1, 0, 0. For checking position and local position, I am creating a script called showPosition. In this script I write transform.position and transform.localPosition for getting position and local position of GameObject. After opening a script named showPosition, in the start method, I wrote a debug log statement with the GameObject's name and its transform.position. The transform.position property is used to get or set the game object's current position in global space. Now, I'm writing a debug log statement with the GameObject's name and transform.localPosition. The transform.localPosition property is used to get or set the GameObject's position relative to its parent's origin, rather than in global coordinates. Now, I will save this script and attach it to both GameObjects A and B. After saving the scene, I will press the play button to run the simulation. As observed in the console window, the position and local position of GameObject A are 2 in the x-axis, 3 in the y-axis, and 0 in the z-axis. Meanwhile, GameObject B's local position is 1 in the x-axis, 0 in the y-axis, and 0 in the z-axis. However, B's global position is 3 in the x-axis, 3 in the y-axis, and 0 in the z-axis because GameObject B is positioned 1 unit to the right of GameObject A in world space. If you're not familiar with what world space means in Unity 3D, click the link I've provided at the end of this video to learn more. It'll help clarify any questions you have about this fundamental concept. In the next video, I'll be creating an editor script that displays the global position or transform.position of game objects. Stay tuned by subscribing to our channel to keep up with the latest updates. Thank you for your support.